Hello there, Nareg is here. Today I'm going to talk about the scalar product or the dot product. So in this video I'm going to talk about the three different methods that you can use in order to calculate the scalar product. But first we have to know something which is very important. Scalar means it is related to scale. So scalar product is a product that will have a certain result, which is a real number. So it's a product between two vectors and the result is a number. Let's start by talking about the first method that we can use in order to calculate the scalar product. So let's say we have the vector u, which is given by its components x and y, and the vector v given by its components x prime, y prime. Whenever I'm going to calculate u scalar v, so it's a scalar product u scalar v, the first definition is that this scalar product is actually x prime plus y prime. So this formula, in order to calculate the scalar product, especially if you have two vectors in the coordinate system or in the Cartesian plane, you can use this formula in order to calculate the scalar product. Now I'm going to take a certain example. Let's say we have A with the coordinates 2, 3, B with the coordinates -1, 2, C 0, 2, and D 3, -5. So how do I calculate, let's say, AB scalar CD? First you should calculate the components of the vector AB. So AB is x of B minus x of A, which is equal to -1 minus 2, it's -3. Y of B minus y of A, so it's 2 minus 3, so it's -1. Similarly, I will have to calculate the components of the vector CD. CD is x of D minus x of C. So I will have 3 minus 0, so it's equal to 3. And y of D minus y of C, which is -5 minus 2, it's -7. Alright, now for the scalar product, so I'm gonna use another color for the scalar product. We can say that this scalar product is actually equal to -3 times 3 plus -1 times -7. So it's equal to so it's equal to -9 plus 7, so it's equal to -2, -2. So this is how you calculate the value. So it's x prime plus y prime in order to calculate the scalar product. Now this was one method. I'm gonna also talk about another method, of course, where we have the geometric angle, where we have the norm of the vector u, the norm of vector v, etc. We're gonna see that in the second part. I'm also gonna talk about a certain case. What if we had, let's say, u scalar u, it's u squared, which is the norm of u to the power of 2. This is some kind of a property that you can use. Let's say we had AB, scalar AB, so it's AB squared. So in this case let's check again. AB was -3, -1. The components were -3. So it's -3 times -3, x prime, plus -1 times -1. So it's 9 plus 1 is 10. So this is for AB, scalar AB, it's 10. So this property that u scalar u is actually u vector to the power of 2, or u, the norm of u to the power of 2. It's a useful property that we can use it easily. Of course, in case you want to calculate from this, you can deduce that AB, the norm of AB is actually the square root of 10. So it's it will remain square root of 10. All right. Just 1 second. Yes. So it will remain the square root of 10. In case you want to add the formula, it's equal to square root of x squared plus y squared. X prime plus y prime times y times y, x times x. So it's the square root of x squared plus y squared. All right, now I'm going to go through the second method in order to calculate the scalar product. In the second method, the definition in order to find the scalar product of u and v, u scalar v, is actually the norm of u times the norm of v times cosine of the angle between u and v. So I'm going to remind you that between two vectors you can have a certain geometric angle. Let's call this u and let's call this vector v. The angle between u and v, I'm going to call it alpha. All right, it's a positive vector since it's from u towards v, so it will remain positive. In this case, I will take an example in order to find out how to calculate the scalar product by using this formula. So this is the formula that you can use it in order to calculate the scalar product. So let's say we have u, and the norm of u is equal to 3, the norm of v is equal to 4, and let's say alpha was equal to pi over 3. So you have to say u scalar v is equal to 3 times 4 times cosine of the angle alpha, of course, pi over 3. So it's 12 times cosine of pi over 3, it's 1 over 2. So the scalar product is 6. Alright, so this was the second method in order to calculate the scalar product. Now there is a third method. Of course, it's quite similar to the second method and it's linked to the second method. But of course, in the third method, I'm going to use the perpendicular projection. We're going to go through this third one. So what about the scalar product? Let's say we have, this is our vector AB, and this is our vector AC. We can, let's say, define AB as u vector and AC as v vector. So let's say I'm interested in AB scalar AC. It will be equal to, of course, it's the same thing as u scalar v. So in this case, I can say that it's AB, the norm of AB, times the norm of AC, times cosine of the angle between AB and AC. So the angle between AB and AC, I'm going to call it, in this case, again, I'm going to call it alpha. So it will be equal to the norm of AB times the norm of AC times cosine alpha. Alright, now there's a very important part here. I'm gonna transform cosine with segments, so I will have to do the projection of C over the segment AB. I'm gonna call this H. And as you can see, the triangle ACH is a right triangle at H. So in this triangle ACH, let's say I'm interested in cosine alpha. Cosine alpha is actually equal to adjacent AH over hypotenuse, which is AC. So whenever I will have to do AC times cosine alpha, whenever I do the cross multiplication, so AC times cosine alpha is equal to AH. And this is the part where you have AC times cosine alpha. AC as in norm, it's the same thing as the segment AC times cosine alpha is the segment AH. So you can transform this formula as AB times AH. Of course, you have to pay attention to the orientation. Whenever AB and AH have the same orientation, they are both on the right side or both towards the left side, your scalar product will be positive. Whenever the angle of alpha is obtuse, so AB is towards right and AH is towards left, you will have a scalar product which is negative. So this is what you should pay attention to. So in most of the books, they simply say that it's AB in algebraic measure times AH in algebraic measure, simply to pay attention to the orientation or the direction. All right, so this was the third method. So you can use the projection of your point C on the segment AB, and then you simply convert your cosine with a segment. The ratio cosine alpha is AH over AC, so AC times cosine alpha is AH. This was the third method. So you have three methods in order to calculate the scalar product. And in this case also, we can simply use the same example if you want the previous values, but you're gonna get the scalar product as 6. All right, that's all for this video. Why don't you subscribe to my channel, because I will be uploading new material, new videos, and I can also share with you my Instagram and Facebook account. You can contact me directly, or you can simply leave a comment below. I hope it was helpful, and see you next time.